teaches it. MathLab gives you all these charts to fill out and all this other stuff, but I think it's the easiest thing to do to solve these kind of problems, which are, they're going to be polynomial inequalities instead of polynomial equations. So they're going to have less than and greater than signs on them. So we're going to try and actually draw these out, because it's going to want to know what part of the function is sometimes greater than, sometimes less than, depending on the symbol, 0. Okay, so let's look at one like number 1. You have x minus 3, x plus 1 is less than 0. Okay, so what I'm going to do is actually draw these out. These are all 7 of these problems are all going to be quad functions. They're going to be x squared, which means they're all going to be U-shaped. Okay, this one may not look like it's quad, but think about this. If you foiled right here, x times x, that's what gives you the x squared. Okay, so this is a U-shaped function. It's just that it went ahead and gave us the factors already. So what I want to know, when you're looking at a graph, right? Here's your x-axis, here's your y-axis. The x-axis is considered the 0, right? That's where your zeros are, or your x-intercepts. It's going to want to know what part of this graph is less than 0. Or in other words, if this is my 0, if I am less than it, that means I would be below the x-axis. So it's going to want to know what part of the graph is less than 0. So I'm going to find the x-intercepts of this parabola. Since it's already in factored form, I'm just going to set each of these factors equal to 0. And solve them for x. So here I would just add the 3 to both sides. So x equals 3. On this one, I would subtract the 1 from both sides. So x equals -1. I'm going to plot those 2 points. These are the x-intercepts of this graph. So I'm going to plot them on my x-axis. So it's going to cross the x-axis at -1 and +3. So -1, +3. So once I do the x-intercepts, then I just need to know, is this parabola this kind or this kind, right? There's 2 different kinds, straight side up or upside down. And what tells you that? What the x squared is, right? If it's negative, that's what flips those U-shapes upside down. If I foil here, x times x, that's going to give me a positive x squared, right? Not negative. So that just means, here's the x-intercepts. It's a right side up parabola. So this is what we need to be looking at. Just the sketch of it. It doesn't have to be exactly. The only thing that's important is that you know which one of these it is and where it crosses the x-axis. Because now I want to know in interval notation, what part of this graph is less than 0? So remember, your x-axis is your 0. So what part of this is less than it or below it? This part right here, right? That part is below the x-axis, which means it's less than 0. So it wants to know in interval notation, right? Interval notations have parentheses, brackets, infinities, negative infinities, that kind of stuff. But let's see. Here's where this is the point where it starts to be below 0, right? And then it's below 0 all the way until it gets to this point. Because then it goes above the x-axis and above 0. So what is that interval? Here, where does it start being below 0? At this x-intercept, which is -1. And it's below the x-axis all until it gets to this point, which is +3. So it is below 0 from the -1 all the way to the 3, right? Because once it gets to 3, what does it do? It crosses through the x-axis and it is above 0. So the interval that it's below 3 or below 0 is -1 to 3. Right, let's look at number 2. X squared minus 17x plus 66 is greater than 0. So this one, the difference is it didn't give me the factors, but it is quad, right? Anytime I just need to know what are the solutions to that. The x-intercepts, the 0. So can I just put this in my quad? Yeah, that'll give me the 2 x-intercepts. So you'll just go to your quad program. Type in your A, B, and C. A is the number in front of x squared, so it'll just be 1. B is the number in front of x, so it'll be -17. And your C is your constant, so it'll be 66. So let's enter those in to get my solution. So 1, -17, and 66. So when you hit enter, you get 11 and 6, right? So 11 and 6 are the solutions, aka zeros, aka x-intercepts, right? All 3 of those terms are interchangeable. So let's think about how that's going to look on this graph. There's my x-axis, it's the 0. It's going to cross through it at 11 and 6. So let's see, 1, 2, 3, 4, 5, 6. So it's going to cross there. 7, 8, 9, 10, 11. And it's going to cross there. So think about where your x-intercepts are going to be. Then draw your parabola through them. So I need to know, is it regular or upside down? That's all I need to know about it. So it's a positive x squared, which means it's regular. Now you always got to check your symbol now. Look at this one. It's a greater than symbol. So it wants to know, where is this quad graph greater than 0? Or in other words, above the x-axis this time, right? If you're greater than 0, you're going to be above the x-axis. So all above the x-axis is here until it gets to that point. Then what happens? It goes below it for a little while, but then what happens here? It comes back above it. So there's actually 2 separate intervals where that graph is above the x-axis. So I want to talk about both of those intervals. So what's C? What does this arrow to the left mean? Where does it start being above the x-axis? At -infinity. And it's above the x-axis until it gets to this point, which means 6. Now remember, that's when you're going to, since it's 2, what do you put in between? If you've got 2 intervals, you'll put that in union with, good, in between them. So in union with, where does it start being above the x-axis again? At 11. And it stays above the x-axis forever. So from 11 to infinity is the other interval. Right, number 3. X squared minus 4x minus 21 greater than or equal to x minus 7. Now remember, before you can put it in quad, it has to be set equal to 0, right? If you don't, you're going to put in the wrong number for your A, B, and C. So let's see, to set it equal to 0, I need to subtract x and add the 7 to knock those out. If I do it on the right side, I have to do it on the left, right? Same thing. On the minus x, make sure you put it underneath its like term. Same with the plus 7. Make sure you put it underneath its like term. So now I'll have greater than or equal to 0. Let's see what I have over here. I've got x squared. Negative 4x minus 1x gives me negative 5x. Negative 21 plus 7 gives me negative 14. So now that it's all on one side, set equal to 0, now you can choose your A, B, and C. So A is in front of x squared, so it'll be 1. B is in front of x, so it'll be negative 5. And C is your constant, which is negative 14. So when I put that in my quad program, let's see, I've got 1, negative 5, negative 14. It gives me 7 and negative 2. So those are the x-intercepts of this function. So let's look at that on the graph. So it's going to cross the x-axis at positive 7 and negative 2. And then remember, you're going to draw your parabola either regular or upside down. Since this one's x squared again is positive, it's going to be a regular. This wants to know, where is this greater than or equal to? So my infinities are always going to have parentheses, right? But this makes, instead of having a parenthesis around the numbers that I'm going to use, I'm going to have a bracket, right? That means it includes that number. That's what the equal to sign tells me. So let's see, above or equal to, greater than or equal to, above it, here, and here. So once again, 2 separate intervals are above that x-axis. So it starts always at negative infinity with a parenthesis around it. So it's above it until it gets to this point, which is the negative 2. And again, it has a bracket around it since it's greater than or equal to. So there's your first interval in union with. So where does it start being above the x-axis again? Positive 7. And it's going to have a bracket around it. And then it's above it forever. So 7 to infinity. Number 4, x squared is greater than 81. So set it equal to 0 first. So I need to subtract the 81 from both sides. So over on the left, I'll have x squared minus 81 is greater than 0. Now, when you put in your A, B, and C, you need to be careful with this one, right? There is a missing term, so you're going to have a 0 somewhere, right? There's only 2 terms, which means one of these is going to have to be a 0. A is always the number in front of x squared. So since I have an x squared, in front of it I have a 1. B is always the number in front of x. That's what's missing, right? There is no x in between here, so that's where your 0 is. Your C is always the constant, which is negative 81. So when you put these numbers in for your A, B, and C, you're going to get negative 9 and positive 9. So those are your X-intercepts. I'll just say that's where positive 9 is, and that's where negative 9 is. My x squared is positive again, which means, again, it's a regular parabola. Crossing through the x-axis at negative 9 and positive 9. Then look at your symbol. Since it's greater than, that means above the x-axis. So once again, just like the last several problems, it's those 2 intervals that we're talking about. So let's see, this one starts at negative infinity until it gets to negative 9. So the infinities are always parentheses. Since it doesn't have the equal to sign this time, the negative 9 also has a parenthesis. In union with, this one goes below until it gets to positive 9, and then it's above it again forever to infinity. All right, number 5. (144) minus x squared is less than or equal to 0. So it's already set equal to 0. Be careful again when you're choosing your A, B, and C. Even if they're out of order, the A is always in front of x squared. So what's the number here in front of x squared? Negative 1. B is the number in front of x. Since I don't have an x, your B is 0 again. C is your constant, which is a positive 144. So when you put those in for A, B, and C, let's see, negative 1, 0, positive 144. There's your x-intercepts, negative 12 and positive 12. Again, your x-axis is where 0 is. So it's going to cross through at negative 12 and positive 12 are going to be the x-intercepts. Now, it is important now you draw your parabola in the right direction. Your x squared this time is negative. which tells me what about this parabola? This one is upside down. It wants to know where is that graph? Less than 0, so here's my 0. What does less than 0 mean you're talking about? Below the x-axis. So again, there's two intervals. Even though it flipped upside down, there's still two intervals because this time they're talking about below the x-axis. So it starts below the x-axis at negative infinity until it gets to negative 12 because that's when it crosses above. Now, does this one have the equal to bar? It does, which means around your numbers, you're going to put brackets. In union with. So it's above it until it gets to positive 12. And again, it has a bracket into infinity, which is always a parenthesis. All right, number 6 has something interesting. How many x-intercepts have all of the ones we've done so far had? They've all had 2, right? Whatever my 2 solutions were in my quad, those were the 2 x-intercepts where the parabolas crossed the x-axis, okay? But let's look at number 6. You've got 26x minus 169 minus x squared is less than 0. So once again, a is always in front of x squared, which in this case is negative 1. That's also telling me that my parabola is going to be upside down, right? Since my x squared is negative. My b is in front of the x. So there's my x. In front of it is a 26. My c is the constant, which is negative 169. So let's see what I get when I put that in quad. Negative 1, 26, and negative 169. When I hit enter on that, it does show me 2 solutions. It's just that they're the same number, right? They're both 13. So remember when we talked about the maximum number of x-intercepts or zeros a function can have, the maximum number is whatever the highest exponent is. It doesn't mean it has to have 2 x-intercepts. It just means 2 is the most that it can have. This one just has 1 x-intercept at 13. So there's my x-intercept. It only has one. Oh, my battery's about to die. It only has 1 x-intercept at 13. And is this one upside down or right side up? Since that's negative, it's going to be upside down. So how is a parabola going to be upside down and have 1 x-intercept? That just means it's going to come up, it's going to touch the x-axis at 13 and go back down. That's how you have, remember, x-intercepts just mean you touch it. You don't have to cross all the way through it. If you crossed all the way through the x-axis and turned around, you would touch it twice. But if you just came up and touched it one time and didn't cross it, you just touched it there and went back down, then you can have 1 x-intercept in a parabola. So let's see, where does it want to know? Where is it less than 0? It's less than 0 all the way until it gets to 13. And then all the way on the other side of 13. So there's only 1 point where that graph is not below the x-axis, right? That point at 13. If this says less than or equal to, then it would be below or equal to the x-axis from negative infinity to positive infinity. But this one is not below the x-axis at 13. So those are my two intervals. There's one open space in my intervals, and that's that 13. So from negative infinity to 13, in union with 13 to infinity. So that essentially says the whole thing from negative infinity to positive infinity except the 13. Last one. X squared plus 18 is less than 3x. Solve it for x, or excuse me, get it set equal to 0 first. So subtract the 3x from both sides. So there's my less than 0. Let's see, I have x squared. I'm going to slide the minus 3x in between those two terms. Plus 18. So my A, B, and C would be 1, negative 3, positive 18. So something interesting also happens on this one. So my A is 1, my B is negative 3, and my C is 18. So look what happens. What do you see in your solutions that you haven't seen in any of the other solutions? An I. So what does this tell me? First of all, it's a right side up parabola because the x squared is positive. So there's my 0. It's a right side up parabola without any x-intercepts, right? You can't put a physical point on an I, right? Where are you going to put it on that number line? There's not anywhere you can put it, okay? Which just means it doesn't cross the x-axis. So it's a right side up parabola. It's a U shape. It's just going to come down like that and not touch the x-axis. So what does it want to know? It's either going to be, if it's above the x-axis, if it wants to know what's greater than 0, it's all of it, right? Everybody's above the x-axis. So negative infinity to positive infinity. That's not what this is asking. It's asking what is below the x-axis here. Well, here's my x-axis. Is any of that U below it or ever going to be below it? It's not. It's going to stay up above it. So that's when, and you'll have this symbol down in your toolbox when you're working this one that looks like that. None of it is below. It's called the null set. None of it is below the x-axis there. Okay. All right. So that is the end of 8.6.